Hello everyone, and welcome to your first Cocoa concurrency tutorial. My name is Lucas, and I'm going to be guiding you through how you can write concurrent code that works for your iOS and macOS applications. The goal of this series is to at least introduce you to the concepts of concurrent programming, and then later get into some examples of when you can use it to improve the performance and to really do things that aren't really possible in other ways. So yeah, this is really just a very large series, but it's a very important one in the world of multiple cores that we live today. So yeah, that's pretty much where this stands. I really want you guys to leave your suggestions on this about anything, brutal performance that you thought it was. Any suggestions that you'd like to give for future tutorials is always a plus. You never know, you might see lesson number X be your idea. So, I like to keep the series pretty dynamic. With that, yeah, let's just kind of get down to the logistics of this set of tutorials. So we're going to be using Swift as the language of choice. So if you want to know Objective-C stuff, again, there's going to be a lot of overlap between these, so don't worry about it. You could probably even write Objective-C and follow along pretty clearly. If you know Objective-C well enough, you should be able to follow along with the Swift syntax. There's really not too much to go over. If you do have a really hard time with it though, I'm going to post both Objective-C and Swift code on my GitHub page for these tutorials, so follow along there if you want, or if you get stuck with that. Alright, so yeah, we're going to be using Swift for that. We'll be writing both iOS and macOS applications and some future examples, so I'm really using Cocoa in the broad sense when I say Cocoa concurrency. What else do I always think I'm leaving something out on this, but I think maybe those are all the points I had to address. Oh, and the other point being, if you don't have any experience with Swift or Objective-C, make sure you get experience with that, I guess, first. If you want to get experience with Objective-C, you can check out any of the tutorials on my channel. There's plenty of them. I'll probably be doing some Swift tutorials in the near future as well, so check out that if you would like to learn about Swift. Alright, so that's that. Let's talk about concurrency. So this tutorial is just about the introduction, and then yeah, let's just dive in. So what is concurrency? Well, let's do a little history lesson on the processor. So you might remember back, I mean, I'm not that old, so I don't really remember back that far, I guess, but I still remember having an OS 9 running Mac, meaning one that really only ran OS 9, and that computer had probably only about, I don't know, I want to say low megahertz, I don't know, I don't really know the exact number, but it had a low number of megahertz anyway at this processor speed. And what processor speed really was back in the day was if you had a 250 megahertz processor, that was essentially how fast your processor was. That's how many instructions it could process. And if you up the frequency, which is really what gigahertz or megahertz is a number of things it can execute per second. So if you had a 250 megahertz processor and then you upped it to a 500 megahertz processor, essentially you could process twice as many instructions, computer instructions per second. So that was sort of the idea. Now, over time, I had a G3 Mac, and that thing I think had about 600 or 800 megahertz on it. We then got a G4. I think we had a pretty high-end one, which was, I don't know, I want to say around 1 gigahertz something. So I think it was a pretty high-end G4 at the time. And then you might know that around nowadays, we've kind of hit this 3, maybe 4 gigahertz zone. And that's pretty much where we've sat as the max value that we go. And why is that? Well, basically we've hit what's known as the power wall. And if you try to make the gigahertz any higher, you are going to burst your CPU into flames. And the amount of heat that gets dissipated when you increase the frequency at this point is too much. So we really couldn't keep increasing the number of gigahertz, because really your CPU would be on fire, and that just doesn't work, because then you have no CPU. So as chip designers, they had to really figure out another way around this, and the solution they really came up with was having multiple cores on the same chip. And so that's why after that period of time you saw dual core, and now we have quad core, and if you're lucky, maybe you have a Mac that has 8 or 16 cores. So that's pretty much where we stand today. And yeah, that's why we have cores, because we really couldn't go gigahertz wise anymore. So that's cool and all. However, there are downsides to that, meaning that we have to really optimize concurrency in our programs, or else we really can't get much more performance out of our applications anymore. Even when new processors come out, it really doesn't mean that the single core application you write will improve all that much if you can't optimize for using other cores. So that is why concurrent programming is important. Now, what are cores exactly? Well, the idea of a core is that you could have, say you have a dual core machine, which this one that I'm running right now actually is. You could run 2 independent processes continuously on those 2 independent cores. So I could run process 1 and process 2 on core 1 and core 2, and they could just go about their day. So in theory, I could run twice as much. Now, that's very theoretical, because if they ever have to access anything that both of them use, then there's going to be problems there. But that's sort of the idea. Now, another term that you'll hear a lot is threads. And threads, in terms of concurrent programming, are not the same as cores. So cores are the physical number of, processing units on the CPU, and then threads are sort of this virtual number that you can have for processing things. So if I have a dual core machine, which means I have 2 cores and I have two threads, they're sort of like the processes. So you can think of threads as the processes, and they can be run on the cores. And so I can run 2 threads at the same time if I have 2 cores. If I have 4 cores, I could in theory run 4 threads at the same time. Now, you can also run more threads. So even though I have a dual core machine, I could run 4 threads. However, I can only run 2 at the same time. If I ran 4 threads, what would end up happening is that the other threads would start fighting for space. So, let's say I spawn 3 threads and I only have 2 cores. Then the other thread that's just sort of sitting there, it's going to fight to get onto one of those cores, basically. So then one of the cores is going to let up, and it'll switch into that thread, and then it'll switch back and forth between different threads, and that's kind of how that works. This is not good, though. If you end up switching between multiple threads, even though you are only working on one core, this isn't really optimal performance, and it actually would slow down a process if you didn't mean for it to, if you didn't mean for the 2 threads to be running at the same time. So that's that. That's sort of a very crash course on threads and cores. Now, in this example that we're going to just do right now, we're going to be running a very simple incrementing example on a class. And we'll just kind of run through it here, and I won't explain until I actually get it fully worked out. So I'm going to say class simple, and we're going to subclass from NSObject. The reason I'm subclassing from NSObject is because I need to be able to use the perform selector method that's part of NSObject, and normal Swift doesn't offer that. So we need to subclass from NSObject. We're going to make our own instance variable called value, or val, and val is going to start out as a value of 0. Now we're going to change this value using a method, and we're going to call this increment val 1000. And as you might guess from the name, this means that we're going to increment value by 1000. And we're not just going to say val plus 1000, we are going to increment this by 1 1,000 times. To do that, we're going to make a for loop, and I'm just going to use the wildcard character there, so that because I don't care about the index, and I'm going to go from 0 to 1000 not inclusive. So 0 to 999, which is essentially 1000. Alright, so if I leave it as so, I can do a very simple example here. I will say new val, let's just call it v for simplicity. V gets val plus 1. Alright, so val is now plus 1 of val. So if val starts off as 0, v is going to be a value of 1. Then I'm going to print the value, like so. Alright, and then the last thing I'm going to do is I'm going to call val, and I'm going to set it to v. So I'm essentially now incrementing what val was. So if val was 0 before, now it's going to be 1. Alright, so that's a very simple code, and well, it's the simple class, so what do you expect? Now we're going to create a new object down here. I'm going to call it S, and we're just going to create a new simple class, or a simple object, I should say. So what we're going to do with S is we're going to call increment val 1000, and we're going to do that 2 times. So if I do this 2 times, you'll see that I'm going to essentially increment it by 2000, right? 1000 times 2, 2000. Alright, so there we go. I run this, and you can see in the console, very nice, I get 2000. Now what does this have to do with threading or concurrency at all? And the answer is nothing. It has nothing to do with it yet. What I'm going to do, though, is I'm going to delete one of these lines, and I'm going to run the same code on another thread. So how can we run another thread in Objective-C? Well, there's a few ways. I'm just going to show you one way in this tutorial, though. What we're going to do is we're going to use the NSThread class. NSThread is a class that's been around for a very long time on for Objective-C stuff, and Simple doesn't have, or sorry, not Simple, Swift doesn't have any special concurrency frameworks as of yet, so we're just going to use pretty much everything that was in the Objective-C frameworks, or the foundation framework, for this. Alright, so what are we going to do? Well, we're going to detach a new thread selector and to target with object. So the selector is simply the method that you're going to call. So we're going to call increment val 1000, and oof, that's ugly. Alright, well, before Xcode goes crazy on me, I'm just going to put this as nil so that it doesn't go crazy on me. This is what happens when beta software is being used, but I promise Xcode 6 will be great when it's not in beta anymore. Alright, so yeah, we're going to call this method. We're going to send it to this specific object. Alright, so again, this method, all it's doing is saying, call this specific method. So you put the method name in string. Again, it's the same thing as a selector was in Objective-C. You want to send this or call this on the specific target, the target being the object that you want to call the method on. And the with object parameter is if there's any parameters you want to send to the method. So in theory, if increment val had a parameter where it's indicated by the colon, and I had a parameter here, then I could actually send that method when it's called a specific object using the with object parameter. But I don't have anything to use it with, so I'm not going to touch it. Alright, so now this is the moment of truth where we have NSThread. This is going to run on a separate thread. That's what detach new thread means. We're going to create a new thread, and the thread that we're running on already is already created for us when we start the program. So we run the program on the main thread, and then we detach a new thread. So we have thread 1, which is our main thread that we start this program on. We detach a new thread, and we create thread 2. Alright, so if I go ahead and run this, we can see that, wow, look at that. We got 12,094. And you can see there's some ugly junk up here too. So you might be wondering, is that a scientifically proven number with threads? And you can run it again. You quickly find out, guess not. Now it's 1570. So nothing is going to stay the same. Now, why is this? Well, like I said, we're running on different threads, and that might not answer any questions to you. The point being is that threads can run at the same time, and there's also really no, even if they're not really running at the same time, it doesn't matter. The point being is that they're both fighting on this same object. So they're both fighting to increment value. And I'll dive into a little slideshow here to kind of show you what I mean by that exactly. So here is an example where I have main thread on the left, or thread 1, and then we have other thread, or thread 2, on the right. And we can run through this. We can see that we set val, or v, to be val plus 1. Then we do some work. In our example, it was printing. And then maybe the other thread now kicks in. So the other thread now kicks in, and it pulls the value of val. Again, remember, val started with a value of 0. So currently, both these threads have value as a value of 0. And so both these threads, their values of v is 1. So if I keep going through this, main thread now set value to be 1, right? Because v was 1, so it sets value to be 1. However, other thread doesn't care, right? It's not interested in the fact that val changed. It doesn't, we never told it to, go back and check value again. So it's just going to set val to what it has v to be, which is 1. So again, the expected behavior that we were sort of looking for was to increment this to be 2000, but the threads are going to break this, right? They don't really care. They're running at different times. They're both accessing the old value at the same time, and so they don't really, the value didn't change, and so they're both getting the old value. And then when we incremented val on main thread, it never got the update on the old or the other thread, and so we are getting various values here. So this is a very simple example of where multi-threading can really bite you if you're not careful with it. It's why threading or concurrency can be very dangerous if you don't know how to approach it properly. But anyway, with that said, this is just a very simple example to demonstrate how threads can work. If you really want to see that two threads are running at the same time on this, we can do something pretty neat as well. We could put a breakpoint in here, and you'll notice that we stop, and actually let me do something else here. I should have also actually, when I didn't mention this before, but I should put in a sleep call here, which is actually quite important. The sleep call makes sure that our main thread keeps running while the other thread is running. So let me actually just talk about that, because that was actually a fairly important point. So when this runs, the NS thread can detach the thread, and as soon as this is run, it's returned, and increment val is going to start right away. So it's not going to run the stuff that's in this thread and then come back. It's going to just, hey, make a new thread, and then it's going to come right back to the main thread, and it's going to start this code. So what can end up happening though is if our main thread finished before the other thread did, then we'd want to wait for that other thread to finish. So we're going to put in a sleep call, and sleep just tells the thread to wait, and this one will wait for a second and then make sure it's done. Alright, so you can see the values there. Now if I put a breakpoint in to this example, so if I just click on the left side over here, that puts in a breakpoint, in case you didn't know that in Objective-C, and you can find some very interesting things that happen. So you'll notice that both of these guys are at different points in this thread. So thread 1, which is actually our main thread, is currently on this point of increment value. And you'll see that thread 2 is at this point of increment value. So it's kind of neat to check out breakpoints when you're doing threaded programming. You can actually check out where each guy is in execution, and it doesn't necessarily always help you, but it's a nice sort of neat thing to check out, at least to know that Xcode does provide this. So anyway, I hope this was a good introduction for you to kind of wrap your head around the concept, at least, of what a thread is. We'll be diving into how we can avoid issues like this in the coming tutorials, and then a lot of other frameworks that Apple provides as well. Anyway, I hope you enjoyed this tutorial. If you have any comments or suggestions, leave them in the comments below, and I'll see you in the next tutorial.